Okay, so for this lesson, we're going to see what happens when you pass by reference. So a quick review, let's pass by value first, and then we'll compare the impact of passing by reference versus passing by value. Let's suppose we have this function, void, and let's call it foo1. And this one, foo1 is the name of the function. Okay, so you can name it whatever you want. And we're going to simply have this signature, which means we're passing by value. So let's go ahead and define foo1, and it will take an int. Let's call it num, and simply we're going to alter the value of num right here and see if that had any impact. You'll see in a minute here. So let's say num now equals its previous value plus 1. Whatever you passed, and we're going to add it, and let's close the curly brace here. So what it's supposed to do is increment whatever value you supply it, increment it by 1, and store it in num. Now remember that num is a local variable within foo1. So that means even if you try to access it in main, you will not be able to do so. And let's prove that. Let's say we have n here. Okay, let's call it n1 for now. And let's assign n1 a value. Let's say 7. And let's call the function foo1 and pass n1 to it. So the intent is that the 7 that's in n1 becomes a value stored in num, and then you add 1 to it, it becomes 8. Then what happens to that 8? Well, let's try to print n1 here. So printf, and notice I'm printing after I called foo1 to see if that had any effect on n1. So n1 equals %d/n, n1. Okay, and let's see what happens here. So compile and run. And let me see here. There is no num1, it's num. So compile and run. And there you go. We're back to 7. So even though it added 1 to that 7, but that was only within foo1. So num had no effect on n1 because they're two different scopes. N1 lives in main and num lives in foo1. Okay? We can print here, printf, num equals, just to show you that it's indeed 8%d/n. We didn't return this value back to main, so it's simply right there. It only lives there. Okay, and let's run it again. So compile and run. As you can see, num is 8, but when you come back, you're printing n1, it's still 7. So you simply gave it 7, incremented it by 1, printed that 8. When you came back to main, it was still 7. Okay, now we're going to have a little twist. I'm going to do this. Void, I'm going to create another function. Foo2. This time, I'm going to have a pointer here. Okay? And we're going to do the same thing with foo2. It's going to do pretty much the same thing. We'll increment it by 1. So we're going to do void foo2, and it will take int. It has its own local variable num. But we have to be careful. This is a pointer. So we're going to call it num, or you could call it numptr if you want. There you go. This has to match. If you want a pointer here, then this has to be a pointer. You know, you're going to ask me, why do we need a pointer? Because remember, pointers, we can assign an address to a pointer. So when I call foo2, I better give it a reference to n1. We'll do that in a minute. So first, let's go ahead and increment whatever we're pointing at. So asterisk num ptr is going to be equal to asterisk num ptr plus 1. Okay? And let's go ahead and close the curly brace. And let's go ahead and call this time foo2. And notice what I'm going to do now, and percent n1. So you're going to pass by reference. And the reason is you have a pointer waiting for that address. Now let's go ahead and print printf n1 after calling foo2 equals, and let's see if it had an effect on it. %d. Notice I didn't do anything to n1 within main. But what happens indirectly by calling foo2, which increments a dereference value to the pointer by 1, and let's do n1 here and see what happens. So let me just move things a little bit here, and let's compile and run. And sure enough, n1 now has literally changed to 8. So numptr as a dereference pointer had direct access to the location in memory where n1 is stored. So there's a huge fundamental difference between passing by value and passing by reference. Notice when you pass by value, you can do whatever you want to that value. When you come back, it will have no effect on the original value that you used as an argument, because you simply passed a copy. On the other hand, when you call a function that requires that you pass by reference, what I have here is an address. What I had here was a value. So this is an actual address that I passed to this function. So since you're passing an address, you need a pointer, right, to handle that address. So you can actually dereference the pointer to access the data at that address. And that's what happened here. So I have full control over this. I can add 10 if I wanted to, right? And let's see what happens when I add 10. So let me compile and run. And notice now I have 17. So I added 10 to 7, right? And so I have full control over n1 remotely through foo2 for the mere fact that I passed it by reference. So that's the major fundamental difference of passing by value versus passing by reference. So if you want to affect a variable that is in main, for example, remotely, pass it by reference. If you simply want to pass a copy for some other function to do something with the copy, and that's it, then pass by value.